I'd like to finish up our videos with a couple examples taken directly from our critical thinking task. In it, we are asked to draw some conclusions about, when we get to the right page, it is section C of our Springdale shopping survey. And in parameters 7, 8, and 9, the people who took the survey gave their opinions about the three malls in 7, 8, and 9, Springdale, Downtown, and West Mall, respectively. And in those values, they rated the malls on a scale from 1 to 5, 1 being dislike very much, 3 being completely neutral, and that's important to our discussion, and 5 being they liked it very much. And we are asked several things. We're asked to do these things for each of the three malls. First of all, they want us to calculate the mean score and sample standard deviation and make some general statement about the mall. Well, we've already done this in the past, and I'll walk through it, and you'll see that numbers look familiar. And once again, we'll find out, yeah, people seem to like the Springdale Mall. That seems to be the place to be. Next, we're asked to do a two-tailed test at the 0.1% significance level and compare the sample calculated mean with a hypothesized mean of 3.0, the neutral value. So what we're saying is that our null hypothesis is that the true population mean is 3.0, even though we calculated a sample mean of something else. We're also asked to generate confidence intervals, and we will do that. That's something we did last week. We get to repeat it. And finally, we get to talk about the p-values associated with our significance, our hypothesis testing. Listed here are the 3 steps we're going to take to get this work done. First of all, we're going to use the data analysis plus t-estimate : mean test, which will give us our mean, standard deviation, and the confidence interval. That's what we did last week. We will then use the t-test : mean, which will give us a p-value. And then finally, we're going to interpret that p-value. And if it's less than our level of significance, we're going to reject H0. Okay, so I'm going to do pretty much what you're asked to do, but I'm going to change one parameter. First of all, we're doing hypothesis testing. And the hypothesis we're testing is that the hypothesis population mean is equal to 3. Well, that's what you are asked to do, but I'm going to do something different. I'm going to say it's equal to 4, just so our numbers don't look exactly alike. What's the alternative hypothesis? It's that the hypothesis mean, population mean, is not equal to 4. And because we have this equal to something versus not equal to that thing, we're looking at a two-tailed test. Okay, so first of all, we need to generate some data. And here is our data. We're looking at parameter 7, Springdale, how much we like them. Values range from 1 to 5, with 3 being neutral. Okay, I'm going to use data analysis plus first of all, just like we did last week. Or was it the week before? They all kind of run together. First, I'm going to use t-estimate mean to generate our mean, sample standard deviation, and our confidence interval. I'll say OK. Yes, I'm going to include the labels, and I believe I need to go to column 2, so I'll just change that. Double check that, yep, column 2 is what I want, because that's my label. I've checked labels. My confidence level, we don't worry about the fact that it's a two-tailed test when we let the computer do the work. It gives us both. single-tailed and two-tailed. Also for our confidence intervals, the same thing. I will now say OK, and there is the data that we need. The true mean from our sample of 150 people who responded to our survey is that the mean value for how much they like Springdale is 4.0867. Now, let's see. You're asked, do they generally like the mall or not? Well, I would probably say yes, it's greater than 3 neutral. It's not 5, but it's between 4 and 5. And here we have the confidence limits. And recall that how we interpret these is that we say the true population mean, we are 90% confident that it will fall between 3.98 and 4.19. Let's just clean this up. Don't like all these significant digits. There we go. We are confident that the true mean, the population mean, based on the sample we drew, we're confident at the 90% level that the population mean is between 3.98 and 4.19. Okay. Now let's go to step 2. We've calculated our mean and our confidence interval. We now need to do a t-test. Well, I first want to do this by hand. Let's see. What do we know? N is 150. Our sample mean is 4.0. What is it? 4.09. 4.09. And the sample standard deviation is 0. I believe it was 0.777. I'm going to need these significant digits to make these things turn out exact. Okay, how are we going to calculate this? Well, our test statistic will be t because we have only the sample standard deviation, not the population standard deviation. It's going to be equal to x bar minus our hypothesized mean divided by the standard error of the mean, which is the sample standard deviation divided by the square root of n. And this will be 4.09, our sample mean, minus our hypothesized population mean, divided by sample standard deviation, divided by the square root of n. We had 150 surveys. I've completed that calculation, and I found that our test statistic is 1.367. Now, we need to find values from the t-distribution table in order to compare our test statistic against. Degrees of freedom, we've got 150 minus 1, which equals 149. However, the t-table does not go up to 149, and so we simply use the infinity row. Let's see. We are a two-tailed test, which means we need to take our level of significance. I didn't write that one down. We were told to do this at the 0.1% level. So when we go to the t-table, we need to look at alpha over 2 because we are looking at a two-tailed test. Whenever we're comparing, looking for the test parameter equaling something versus it equaling not that thing, it is a two-tailed test. And so we're going to be pulling a value at the 0.05 level. And if we go to our table, I'm going to do this again. This is live, folks. Let's see, the infinity row in 0.05 gives me a test parameter of 1.645. Okay. Now we are ready to draw some conclusions. Let's see, I'm running out of room here, and I want to be able to draw a graph. I guess I can get rid of this for right now. There's our t-distribution. There's our two tails. Of course, this is the region of accepting H0, and the ends are where we reject. Our t-table value is 1.645. And our test statistic that we calculated was somewhere else. It was inside of 1.645. It was 1.367, which tells us one thing. We are not able to reject the null hypothesis. No, we must accept the null hypothesis. That tells us that the hypothesized population mean is actually equal to 4. Now let's run those numbers with Excel and see if it agrees. Okay, to do that, again, we're looking for Data Analysis Plus, and this time we run t-test of the mean. We place in our hypothesized mean. Recall, I'm hypothesizing that the population mean is 4. That's not the value that you will use. No, you are going to compare it to 3. I need to put in the proper range here, and I don't know why this thing changes by 1 every time you do this, but okay. And there's my results. First, I'm going to go get the results from the other table, just so we can look at them together. I'll paste these in here. All right, let's see. Let's shorten up significant figures here a little bit. What have we found? Boy, that's a lot of numbers. First of all, initially we calculated a mean of 4.09 standard deviation, and we made a confidence interval. The work we just did resulted in a t-statistic of 1.37. Now you may recall that we also resulted in a t-statistic of 1.37. Now, because we are looking at a two-tailed test, these are the values we are actually interested in looking at. The one-tailed test really don't matter to us here. We're looking at a two-tailed test. And it says, first of all, the critical t-value is 1.66. Well, that rings a bell because that's exactly what we found in our t-table with degrees of freedom of 149, alpha 0.05, or significance level of alpha over 2 being 0.05. We found 1.66. So far, so good. Now here's what we need to do for the interpretation. This is the probability that our t-value is less than or equal than the t-statistic. Our p-value is 0.17. And again, how do we evaluate the t-statistic? I'm sorry, the p-value? If the p-value is less than our level of significance, we'll reject H0. P-value less than the level of significance. Is it? Well, our significance level was 0.1. And our p-value is 0.17. Is p less than, is our calculated p-value less than our significance level? No, it is not. And so we are not going to reject H naught. We are going to accept H naught, that yes, the mean is equal to 4. And that's the same thing that we found when we did it by hand. We were unable to reject the null hypothesis. Let's see if this makes sense given the confidence interval that we calculated. We proposed or hypothesized that the population standard deviation is equal to the sample mean, and that it had a confidence interval surrounding it of somewhere between 3.98 to 4.19. Well, let's see. We were proposing that our mean was 4.0. Does 4.0 fall within that range? Yes, it certainly does. Leading us to the same conclusion, no matter how we look at it. We accept H naught, that the mean is 4. We did it by calculating our test statistic, and you can see that we would also conclude the same thing looking at our confidence interval. This is the similarity between the two. Okay, let's move a little bit away from 4.0. Let's run this test again and say, I'm not going to hypothesize that it's 4.0. Let's say that it's 3.9. Now that's not moving much, but recall these are pretty small numbers we're dealing with, and that's a pretty significant change. So I'm going to go back to my data set. I'm going to run it again, the t-test. This time I'm going to use 3.9 as my hypothesized mean. Get my data range correct. Say OK. And now what have we got? Well, there's my hypothesized mean. Again, we're interested in two-tailed tests. Let's get these guys back over here so we can make that comparison. Let's see. Now that we've said the hypothesized mean is 3.9, what does our two-tailed test p-value fall at? 0.004. 0.004. What does that tell us? Well, I'm going to need a little bit more significant figures in order to see that. Let's see, I want more like that. Okay. Is this p-value less than our level of significance? Yes, it is. And what do we do when our p-value is less than our level of significance? We reject H naught. In this case, this second case, we've changed to 3.9 as our hypothesized population mean. And in this case, our p-value is less than the level of significance. We must reject H naught and say, sorry, alternative hypothesis rules. The population mean is not equal to 3.9. Okay, let's see. Does our confidence interval tell us the same thing? Well, sure enough, it does. We were 90% confident that the population mean was between 3.98 and 4.19. 3.9 falls outside that range. Thus, you can see the relation between confidence intervals and hypothesis testing.